I'm now here with Peter Adam from Siemens Energy, here at our media center at the World Hydrogen Congress in Rotterdam. Peter, thanks for joining us. Here, it's a pleasure to have you here and to talk with you about Siemens Energy's perception on hydrogen. Before we start talking a bit more about Siemens Energy, I would like to hear your personal journey to hydrogen and also to your position at Siemens Energy.
Okay, I started with Siemens Energy more than 40 years back as a commissioning engineer for industrial applications, and then doing basically everything you can imagine in the company over the many years I am with first Siemens and now Siemens Energy. And roughly, I think 2.5, 3 years back, we said, okay, this topic of sustainable energy, hydrogen, decarbonization, getting more and more speed, and we need to start to focus on it. And then, wow, I say, okay, this is something interesting for me. And then I started basically to look at this. And then in the up to end of September this year, we had this industrial application division, where then we said, okay, I take care in the division, and in particular for the compression business, to identify the market trends, initiate developments on new products if required, develop projects, create awareness in the company, what is needed, what business models, talk to customers, that we really position ourselves. And in a nutshell, hydrogen is not new. Because I think the first steam reformer was built 100 years back to make nitrogen fertilizer. I think the first hydrogen pipeline in Germany was built in the Ruhr Valley in 1936, still in operation. And we sell hydrogen compressors since, I don't know, decades. Of course, clear as this was always for industrial purposes. The volume flow was relatively small. Typically, hydrogen was produced where it was consumed later in mainly ammonia or refineries or in maybe methanol processes. Nevertheless, we have on this planet already some 5,000-6,000 kilometers of hydrogen pipelines in Europe and in the US. So again, it's nothing new. What's new is, of course, green hydrogen. What is new is that the gray hydrogen need to become blue, means need to be decarbonized. And of course, we will see much, much, much more capacity. And that also means we need some new products that are not available today.
Exactly, and talking about these new products and especially these new projects around green hydrogen, I mean, you as Siemens Energy, you're involved in projects all around the globe, like on every continent. And do you already see where there's the largest potential in a quick realization of these projects?
First of all, I think everything in Europe is complicated, because it takes long. We have a lot of legislation and a lot of people to discuss about. So we have those big projects in the North Sea and some others. So, but okay, they are big in the below 5 gigawatt range in electrolysis and pepper. So my opinion is, or feeling is, we will see the first hydrogen pipelines in Europe, maybe using repurposed gas pipeline to hydrogen, where more or less some projects are already at a stage that an FID could be made, but missing regulations is stopping this at the moment. So basically, if, for example, the German government would now finally conclude what is the fee the pipeline operators get when they report hydrogen, what is the most important part of the business case, we could start really to enter FID tomorrow. It's small scale projects like Get H2, for example, in Lingen. Whereas when it comes to the very large green hydrogen and subsequent ammonia, methanol or something projects, maybe I see the biggest potential at the moment in countries like Australia, Oman, South America, because we need to be realistic here in Europe. When it comes to the very large scale, you need a lot of space for the photovoltaic, for the wind. And here in Europe is always a challenge because, we have the NIMBY effect and whatever else. Definitely. We see single projects in Australia where developers have secured land rights for 100 years in the size of the Saarland, just for one single project, installing 25 gigawatt of renewable energy, mixed wind and solar and subsequent photovoltaic. And they target FID even earlier than the 2-3 gigawatt size wind projects we have here in Europe. So this is for me, when it comes to really to big size, it's Australia, South America, where you have abundant space, you have good wind and solar conditions, and you have a stable political environment that would allow such investment. Because clear is, when we remember the exercise with Desertec some 10 years back, at the end it's failed because no one wanted to build the infrastructure and no bank would finance or no insurer would insure in a total political unstable area like Libya or Algeria, where that's why the project didn't go ahead.
Yeah, true. So interesting take on this one. So political framework conditions on the one side, but also creating support schemes in the regions to be able to fastly implement these projects is one of the key aspects for you to fastly implement these projects.
What I really see that the recent changed new legislation in the US, this Inflation Correction Act, I believe will draw a lot of investment to the US short term because it's just simpler. So here in Europe, you have to fill out 2,000 pages of application and talk to the local government, you talk to the EU and whatever else. Everything is very complicated, take a long time, a lot of administrative hurdles to go ahead with something. Whereas I believe such a simple regulation, you just get a $3 credit if you use green hydrogen. I think this will cause a lot of project activities move originally intended in Europe to the US. A little bit too early to tell exactly what it is, but I do not see those mega projects in the US. I see more mid-sized projects, many of them. Because also in the US, you cannot easily just say, I have this giant space and put everything full of renewable power.
That's true.
This is anyway for me the biggest problem. When I look at the whole prediction of the green hydrogen, to make 1 ton of green hydrogen, you need 55 megawatt hours. That is physics, you cannot change it. Then it's easy to calculate. If all the hydrogen the world thinks it needs in 2050, let's say 700 million ton maybe, you need more than 40,000 terawatt hours electrical energy to make this is green hydrogen. And when in parallel we want to retire all the coal-fired power plants, we step out of nuclear, want to do electrification heat pumps, really, it's for me, the obstacle is not so much, of course, the limited capacity on electrolysis. It's much more, I don't think we will be able to install the gigantic capacity of renewable power that is required in the short time. At least politicians think it's possible.
Okay. Yeah, definitely. I mean, the global supply chains is definitely one of the big issues that were discussed in this conference as well. But also talking about supply chain, I mean, Siemens Energy, aside all the projects you're involved in, you're especially also supplying components along the complete value chain of hydrogen. And one specific topic that was mentioned here is H2 ready. I mean, of pipelines, of components, of materials. And I mean, we together developed a guideline for H2 readiness for combined cycle gas turbines. Do you see from your customer perspective, like is the customer requests for H2 ready setups, solutions, components rising in the last few years strongly, or is it more or less stable?
Of course, the expectations are rising. When you put yourself in the shoe of a customer, this is, wow, hydrogen is coming. I do not know how quickly it's coming. For big power plants, probably it will take a long time until a sufficient quantity of hydrogen is available to run a large combined cycle power plant with hydrogen. So if I'm a customer, I say, wow, I'll buy a turbine now. I want this turbine that it can run on natural gas today with the best performance. And in 20 years, when I may have sufficient hydrogen, it runs on this. But I believe this is a little bit wishful thinking. We have it because I believe when we have now the engines ready to a certain degree on hydrogen, where any operator can be sure he can operate his plant for the next 20 years, because before he will not have more hydrogen And then maybe with some adjustment in the combustion system to make it even more ready for 100%. Because this is then not the auxiliaries and all the stuff you talk about, or of course you need to have. This you can install now. It's more the heart of the system, the combustion system, but of course always need to be optimized to the thermal properties of the gas you burn, what is just different between natural gas and hydrogen. So that's something where I believe high expectations, but also realistically it goes on, because I believe the operators more or less realize, okay, I will not have any quantity of hydrogen that allow me to run the power plant 100% maybe in the next 20 years.
Yeah,
there are some exceptions with smaller plants where it's tested, but on the big scale, I don't think so.
Yeah, but still no one wants to end up with a stranded asset with a large investment like a gas turbine.
But this is then on us, on the industry basically, to ensure and guarantee to the customer that we can upgrade your engine that is ready. I don't think there is a risk of stranded assets.
Yeah.
Absolutely not. Because at the end, you need to change the combustion system somehow, and that is even available today. Yeah.
But I think this is also, this is part of being hydrogen ready. It means also that you can upgrade the system.
Exactly.
So that it means you don't have to exchange the whole system, but you can upgrade parts of it, and then it can run on hydrogen, if it's blended hydrogen or 100% hydrogen.
When it comes to the compressors, we sell hydrogen compressors since 50 years.
Yeah.
So at the end, when you have a syngas machine in some processes, you have a very high hydrogen content, very low mole weight. So all auxiliaries, all the machinery is already available since decades for this. So we not much need to change. Of course, there's one missing product, and that is a hydrogen turbo compressor. Because when we have much higher volume flow, as we can expect in the future for pipelines, we cannot handle with the equipment we have.
Yeah.
So that is what we started 2 years ago, that the industry said we want to have the same delta P compression performance we have today for natural gas in a single compressor casing in our compressor stations for pipelines.
Yeah.
This technology was not available this time, because physically it means the impellers of the compressor needs to have a much higher tip speed in the magnitude up to 700 meters per second. Today we have half. Then we started the development of a new impeller technology that is able to withstand the much higher centrifugal forces of higher circumferential speed, as well as being resistant to hydrogen embrittlement. But this is nearly ready, and we already started dialogue with customers on piloting those machines in their pipelines, facing the same problem we have on the gas turbine side.
Yeah.
But the customer said, wow, great, I like the machine, but when you can give me the machine in early 24, I don't have the hydrogen to really use it. This is always a hen and egg issue that clear when a customer says, I now want to make want to build a hydrogen pipeline. And in Europe, the consensus is we have 100% hydrogen pipelines. Yeah. So the pipeline has a capacity of 100%. So, but when they start, it's maybe 10 or 15 or even less.
Yeah.
Then you have a machine that ideally should be able to run the 100% flow in the pipeline. But this machine can never work efficiently when you only have 15% flow available. Well, that is where we are in discussion with customers how to resolve this. That we say, okay, a compressor cannot run efficiently with only 15% of the flow it is designed for. So therefore, probably we have to find solutions that we combine small compressors that deal at the beginning with the low flow, and then the other machine that takes over when the flow increases. And in particular, when at the end of a large electrolysis system or at a pipeline that is fed by electrolysis system with renewable energy, it's clear the flow of the hydrogen goes from 0 to 100%, depending on whether you have wind or solar. And that is then where we are in progress to develop jointly with the customer the compression concept, how we can deal with this. Because clear as in the natural gas network we have today, it's natural gas, we always have a flow that these machines can run, but they cannot run with 10% capacity. So that is ongoing dialogue, and I'm confident that we have a solution. It's then the question when the regulatory framework is set, that the customer say, okay, I need to bite a bullet and install such a system. What of course, at the end, makes it more expensive.
Yeah.
But the flow pattern we have on hydrogen will fluctuate, and until we really have a constant flow in the grid, will take a long time. Clearly, as eventually 10, 20 years down the road, when we have enough hydrogen produced, we also have a more constant flow that we can say we can optimize the compressors to this flow.
Sure. Okay, thanks a lot. I mean, this was a good explanation around the hydrogen ready topic and why this is not as easy as some people might think.
But on the other hand, I really have to say, when it comes to the rotating equipment, what we provide, I would say nearly everything is available. There's not much to do. From the compression side, as I pointed out, is only to deal with the higher volume flows, where we are ready to pilot with customers. On the gas turbine side, you're aware that we, as we speak, we commission gas turbines with 60-70% hydrogen. So we know we have this pilot to make with dry low emissions 100% hydrogen available for a pilot plant in France next year. So all those technologies are or will be available long before the customer ever have sufficient hydrogen to use it 100%.
Okay. Then perhaps one last question before we end this interview. Siemens Energy, we talked about the lack of electrolyzer capacity in general, also to be able to supply the demand we're expecting to have in the near future, even 2030. So how are Siemens Energy plans then to ramp up their own production of electrolyzers with respect to this lack? Are you thinking about increasing your plans?
Absolutely. No. When you see the recent public announcement, we are in progress to ramp up and build a new facility in Berlin in the 2+ gigawatt capacity size. But this is again a hen and egg issue, because at the moment with the projects that are really have FID, when the customer is buying something, it just doesn't justify these capacities.
Yeah.
So it's clear when we look at all what is developed. My opinion is the world needs much more capacity in electrolysis plants or OEMs that the combined plan of all the OEMs have.
Yeah.
So that will be a challenge, yeah? That maybe when we realize it, that really the demand is there, that customers really intend to buy something, because it doesn't make sense for us to build a factory and then we cannot fill it because there is no real demand there. The demand is more at the moment doing studies, doing concepts. And then the idea is, we need really the quantity of the electrolysis systems in maybe earliest 26, 27, 28 or later. So, and we cannot put in stranded assets, but the plans are there. They are started to execute it, and we hope that we are able at the end to exactly ramp up our capacity to what really the market offtakes.
Okay, perfect. Well, thank you very much, Peter, for sharing these insights from your experience with hydrogen, Siemens Energy views on hydrogen ready, on the ramp up of the electrolyzer capacity, and also on the global development of projects. So really looking forward to get more news during the next year about Siemens Energy's plans and projects.
In a nutshell, for me, all those hydrogen economy establishment is less a problem of technology. At least from our perspective, most technology is available or will be readily available in the near future. Yeah. It's more lack of legislation, financing, altogether, this kind of stuff.
Yeah, then let's see how this develops in the next year then. Hopefully in a good way.
I fear that at least our government has other worries at the moment and they may not have the time to focus on this.
But unfortunately, there's other areas in the world that really strongly push this topic.
Absolutely. Thank you.
Thank you very much.
See you. Bye.